Imagine floating in silence. No sound, no ground beneath your feet, only the endless black of space. And then, faintly, a shimmer of light appears, a whisper from the past. Not years, not centuries, but billions of years echoing forward. This is what the James Webb Space Telescope was built to see. Suspended in its cold perch at Lagrange Point 2, Webb is humanity's most ambitious time machine, an eye that looks back to the very dawn of time. And what it has seen was never supposed to exist. For decades, we thought we knew the script. The universe began small, chaotic, hot. Stars formed, galaxies grew. Black holes, the monsters of the cosmos, started tiny, then swelled slowly over billions of years. That was the blueprint. But when Webb opened its golden mirrors, it found something shocking. Instead of cosmic toddlers, it saw giants, fully formed, supermassive black holes, tens of millions of times heavier than our sun, already sitting in the first billion years of the universe. This was never in the plan. By our models, there simply wasn't enough time. Black holes were supposed to be born from dying stars, then grow through eating and merging. That process takes billions of years. Yet here they were, fully grown, far too soon. One galaxy, ZS7, became the smoking gun. Webb detected a furious swirl of gas, unmistakable signs of a feeding black hole. When astronomers calculated its size, the answer stunned them. 50 million solar masses, less than 740 million years after the Big Bang. By the rules of physics, it should not exist. And it wasn't alone. Webb kept finding more. The conclusion was undeniable. Our cosmic blueprint is wrong. Why could Webb see what Hubble couldn't? The answer lies in light itself. The early universe was wrapped in thick clouds of dust, hiding the galaxies being born. To Hubble's eyes, they were opaque, but Webb sees an infrared, which slips through dust like sound through walls. Suddenly, the veil was lifted, and the universe's secrets were laid bare. Scientists scrambled for explanations. One theory, these black holes grew fast by cosmic cannibalism, colliding, merging, devouring each other. And Webb confirmed mergers were real, capturing the earliest and most distant black hole collision ever seen. But even this wasn't enough. The math demanded far too many mergers, far too fast. The puzzle remained unsolved. Which led to a radical idea. What if black holes didn't start small at all? What if vast clouds of gas in the early universe collapsed directly into massive black holes, skipping the star stage entirely? This is the heavy seed hypothesis. It explains the timeline, but it breaks the rules of physics as we know them. Gas should fragment into stars, not collapse into one monster. If this theory is right, our understanding of cosmic birth is fundamentally incomplete. And Webb's surprises didn't stop there. When it turned its gaze closer to home, into the Orion Nebula, astronomers found something even stranger. Pairs of Jupiter-sized objects drifting together, not orbiting stars. Astronomers call them Jupiter mass binary objects, or jumbos. The problem? They shouldn't exist. Planets are supposed to form around stars. Rogue planets can be ejected, yes, but in pairs? Bound together in deep space? That defies everything we thought we knew. Yet Webb found dozens. Another quiet reminder that the universe plays by rules we don't yet understand. And then came perhaps the most unsettling clue of all. One of the pillars of cosmology is the cosmological principle. On large scales, the universe has no preference, no cosmic up or down. Galaxies should spin randomly, with no bias. But Webb's survey of 263 distant galaxies showed otherwise. 2/3 of them were spinning the same direction. Statistically, this should be impossible, unless the universe itself has a spin, a rotation inherited from its birth.
Some radical models suggest our cosmos was born from the collapse of a star in a higher dimensional reality. That collapse could have seeded our universe with angular momentum, a kind of cosmic twist. It's speculative, controversial, but the fact that serious scientists are now discussing it shows just how destabilizing Webb's discoveries are. We built Webb to give us answers, to confirm our models, to polish our theories, to close the gaps. Instead, it has become something else entirely, a question machine. Every image, every data set, every discovery forces us to confront how little we know. The impossibly massive black holes, the rogue planetary pairs, the galaxies spinning in unison. Each one is a thread unraveling the neat story we thought we understood. The universe is not tidy. It is stranger, darker, and more mysterious than we ever dared imagine. And perhaps that is Webb's greatest gift, not the answers it provides, but the courage it forces upon us. The courage to throw away old maps and explore again, without certainty, into the unknown. So, the next time you see one of Webb's breathtaking images, a nebula glowing like a ghost, a galaxy painted in impossible detail, remember, you're not just looking at a picture, you're looking at a challenge, a reminder that the universe does not bend to our expectations, that the story we wrote is not the story that was lived. The James Webb Space Telescope has pulled back the curtain on the deepest secrets of the cosmos, and what lies behind it is not clarity, but mystery. And the most unsettling truth of all